The NaviTrack Scout cable, pipe, and sonde locator is a critical part of any successful pipe and cable locate. With NaviTrack Scout, you can pinpoint remote transmitters like the one in your Sea-Snake camera system and trace buried utility lines. Scout makes locating fast, accurate, and easy, so you can dig with confidence. In the next few minutes, we'll show you how to set up NaviTrack Scout to work with your existing equipment, show you some basic and advanced techniques for locating remote transmitters, and demonstrate the basics of tracing buried pipes and cables. To install the batteries, locate the battery compartment on the bottom of the receiver and turn the locking knob a quarter turn to release the battery holder. Install the batteries with the correct polarity, as shown on the label inside the battery holder. Scout ships with high-quality alkaline batteries, but rechargeable batteries may also be used. To prevent damage to the batteries or to the unit, never mix rechargeable and standard battery types. Press the menu key to open the list of frequencies available. Use the up and down arrows to highlight the frequency needed for the job. Be sure to match the mode used for the equipment you are locating. Press the select key to check the box and activate the frequency. See the operator's manual for detailed instructions. In this segment, we'll locate the remote transmitter or sonde in our Sea-Snake camera system. We'll show you how to find a sonde based only on the strength of its signal, and how to use the map in conjunction with signal strength. These techniques will give you the tools you need to be successful in any situation. Before we put the camera into the line, we'll test our equipment to make sure the transmitter is operating correctly. Our camera system is set up, so we'll place the camera head on the ground next to our access point. The transmitter, or sonde, is located inside the spring, right behind the camera head. We'll turn the receiver on, and when the operating screen appears, we'll use the frequency key to select a sonde frequency of 512 Hz to match our transmitter. We haven't activated the transmitter, and the receiver isn't registering a signal. This tells us the area is free from interfering signals that could reduce the accuracy of our locate. When we do activate the camera's remote transmitter, Scout registers a strong, stable signal. Our equipment is working, so we'll go ahead and put the camera in the line. Sondes have a limited transmitting range, so we're only going to push out a few feet before we locate. In this case, the line ties into the main line after about 15 feet, so we'll push just past the T and go locate the camera. For our first locate, we'll find the transmitter using the receiver's audio tone and its signal strength readout, which is highlighted in the picture-in-picture image. To find the transmitter's general direction, our technician will hold the receiver out in front of him and sweep it in an arc, using the signal strength number and audio to zero in on the strongest signal. When the signal strength is highest, the receiver's mast will be aimed at the transmitter, so he'll lower the receiver and walk in that direction. As he approaches the transmitter, the signal strength will increase. When he passes the transmitter, the signal strength will begin to decrease, so he'll stop and move back to the point where the signal was strongest. This puts him very close to the transmitter. To pinpoint the transmitter, he'll move the receiver backwards, forward, left, and right until he finds the strongest signal. When he finds the point where movement in any direction causes the signal to decrease, he's directly over the transmitter. Next, we'll push the camera about 30 feet down the line and go locate it again, this time using both the map and signal strength. Let's take a look at how the receiver's mapping display works. The map uses icons to represent the position of targets underground. There are two types of targets: poles, which occur at each end of the sonde, and the equator, a plane that crosses over the center of the sonde. If you draw a line between the two poles, the sonde would be located where that line and the equator intersect. The receiver's display uses icons to represent the position of the poles and the equator. We can map these points by targeting their icons on the center of Scout's display. In this example, our technician will use signal strength to find the direction of the transmitter, just like he did with his first locate. Once he has the transmitter's direction, he'll walk toward the transmitter. When the signal strength begins to decrease, he'll stop and back up to the point where the signal is highest. The signal strength seems to be highest over the equator, which is a good indication that the remote transmitter is horizontal and that its signal is not distorted. He'll map the transmitter's position by finding and marking the poles and then the equator. As he approaches the first pole, the pole icon appears. He'll center it on the display and mark its position with one of the orange markers. The second pole is on the other side of the equator, and he'll find it and mark it just like he did the first pole. Now he'll move back toward the equator and look for the point where the signal is strongest. In this case, the sonde is horizontal and its signal is undistorted, so the signal is strongest over the equator. After he's verified the signal is strongest over the equator, he'll measure the sonde's depth. To accurately measure depth, the lower antenna housing must be touching the ground, the equator must be centered on the crosshairs, and the receiver must be level. You can use the bubble level on the receiver's face as a guide to help you keep it level. When the receiver is properly aligned with the signal, you'll see the depth reading at the bottom left of the display. If you aren't getting a depth reading, rotate the receiver in the direction shown by the arrow. When the arrow disappears, the receiver will display the depth automatically. To double check his depth, he'll rotate the receiver 180 degrees. It should be close to his first measurement, which it is. When he's finished, he has 3 indications this is a good locate. The sonde marker is in line with the pole markers and about halfway between them. The signal strength is highest over the sonde marker, and the 2 depth measurements are very close to one another. In this example, we'll demonstrate a variation of the technique we just showed you. This is the same locate we performed earlier using just the receiver's signal strength indicators. But this time, we'll use the equator line on the display to guide us to the sonde. When you're close to the transmitter and getting a strong reading on the equator, you can follow it right to the transmitter. We'll keep the equator roughly centered on the display as we follow it. When we pass by the sonde, the signal will begin to decrease, so we'll stop and find the point where the signal is strongest. Then we'll move the receiver in front of and in back of the equator to make sure the signal is strongest when we're directly over it. It is, so we'll rotate the receiver to take a depth reading. Then we'll check it at 180 degrees. Both depth readings are consistent, so we'll mark the sonde's location. We'll finish mapping our locate by finding both poles. When we're finished, we'll have the same results as with our previous locate. The sonde marker is in line with and about halfway between the poles, the signal is strongest over the equator, and our 2 depth measurements closely match. This example demonstrates just how flexible Scout can be. For our final example, our technician will be locating a rigid Coleman float sonde. The float sonde is a small battery-powered transmitter designed to float freely down the line. Because it's not attached to a push cable, there's no guarantee the float sonde's antenna will be horizontal. This means we won't be able to use Scout's mapping display or automatic depth features. Our technician will have to rely on signal strength to locate this sonde. He'll start by sweeping to find the general direction and walk in that direction. When the signal begins to drop, he'll stop and back up to where the signal was highest, just as he did in our previous examples. This time, however, he's nowhere near the equator. This tells him he's probably dealing with a non-horizontal sonde. He'll pinpoint the sonde by zeroing in on the strongest signal. Notice that he's taking great care to keep the receiver at a constant height. That's because a 1-inch difference in the height of the receiver affects the signal as much as about 6 inches of lateral movement. For greater accuracy, he'll make his final measurements with the lower antenna very close to the ground. The automatic depth feature only works when the equator is centered on the crosshairs. To get a depth measurement under these circumstances, he'll press and hold the down key to force a depth reading. The initial depth reading of greater than 15 feet means that Scout's upper antenna isn't aligned with the signal, so he'll rotate the receiver until he gets a valid depth. This example demonstrates how important it is to always verify you found the strongest signal before marking the sonde's location. In the past few minutes, we showed you the basics of locating a remote transmitter. Here are a few key points to remember. When marking the poles and equator and measuring depth, make sure the lower antenna ball is touching the ground and use the bubble level on the receiver's face to make sure the receiver is level. You can use Scout's mapping functions to help you find the sonde or to confirm your locate, but always mark the transmitter's location at the point where the signal is strongest. When you're making your final signal strength measurement, keep the receiver at a constant height. Even slight variations in height can cause drastic changes in the signal strength reading. Scout's automatic depth feature only works when the equator line is centered on the display. When the angle indicator in the upper right corner of the display reads 5 or less, the equator is centered well enough for Scout to display the depth automatically. In this segment, we'll demonstrate the basics of using Scout to trace buried lines. In this example, we'll trace the signal applied to a water line with a NaviTrack line transmitter, but you would use the same technique for any type of line. We've connected to a backflow valve that tees into the main water line about 15 feet away. Lower frequencies tend to travel farther and bleed less, so for this job, we've selected the transmitter's lowest frequency, which is 512 Hz. We'll turn the receiver on and use the frequency key to select a line trace frequency to match our transmitter. If you haven't already activated the line trace frequencies in your receiver, you can do so in the settings menu. See your user manual for details. Before we go locate our water line, we'll make sure we're receiving the transmitter signal. We have a good strong signal, so we'll go pick up our target utility. When we approach the target utility, the tracing line will appear in the active view area. The tracing line indicates the approximate location and direction of the signal radiating from the target utility. If we're picking up a good undistorted signal, the signal strength will be highest when the line is centered on the crosshairs and will decrease when we move the receiver to the right or left. In this case, the signal strength is not highest when the tracing line is centered. This is one indication that our signal could be distorted. Next, we'll take a depth measurement. To get a depth measurement, the tracing line must be centered on the crosshairs, and the lower antenna ball must be touching the ground. Next, we'll rotate the receiver in the direction indicated by the arrow until the depth appears. Now we'll take another reading by rotating the receiver 180 degrees. In this case, the two depth measurements differ greatly. Our signal appears to be distorted, so we'll look for an alternate connection point. We have access to the main water line at the meter, so we'll connect our transmitter there and try our locate again. This time, the signal is highest when the tracing lines are centered. And the two depth measurements are close to one another. Everything looks good, so we'll proceed with our locate. We'll keep the tracing line roughly centered on the display as we walk, and let it guide us along the target utility's path. We'll also keep an eye on the signal strength, which should remain reasonably stable during the trace. When we're ready to mark the line, we'll check the signal strength and depth, just as we did before. Here are some key points to remember when you're tracing a line. Check for signal distortion before and during your locate. If the signal appears to be distorted, You may be able to reduce the distortion by using an alternate connection point, or by isolating its ground from nearby utilities. Use the tracing lines as a guide to help you follow the utility's path, but always mark the line where the signal strength is highest. In the past few minutes, we've introduced you to the NaviTrack Scout. Before using Scout, be sure to read the operator's manual. The operator's manual contains detailed information on the equipment's features and operation, and will help you get the most out of your equipment. From all of us at RIDGID, thank you for buying the NaviTrack Scout, and thank you for watching this video.